Very good morning to all of you. Myself, Dr. Gopal Arora. I am here working as professor in School of Engineering and Information Technology in the Department of Chemistry. Um, Today I am going to present a lecture on topic Introduction of Fuels. Mm, In this lecture, we will discuss about the introduction of fuels, how these fuels are to be classified, and what are its units, and the other thing is how we can measure or determine the calorific value of a fuel. These are the topics that we discuss one by one. So first we start with the fuels. What are fuels? Fuels is, as you know about the basic definition, that a chemical substance or combustible substance which on burning it produces huge amount of heat, and this heat is to be used for industrial applications and other household applications. So what is the criteria of a good fuel? So this fuel is basically eco-friendly, produce less residue, high calorific value, easy to store, easy to transport. These are the things or characteristics of a good fuel. Fuel is defined as a combustible substance that is used to produce heat or power by combustion, and any chemical process accompanied by the evolution of light and heat is called combustion. The basic thing that is required for combustion is oxygen. So as you see that if any fuel burns in the presence of oxygen, it produces the product, and you can say that the residue or heat, and this heat is used for the industrial work as well as household applications. So this is the product or residue that is obtained by the burning of fuel. Here we focus about the classification of fuels. So this fuel is classified on the basis of the occurrence and on the physical state. So this, if it is solid fuel, the example of solid fuel is wood and coal. If it is liquid fuel, then crude petroleum, natural gasoline, these are the example of liquid fuel. And gaseous fuel includes natural gas. On the basis of its occurrence, it is primary or natural fuels, secondary or prepared fuel. So secondary or prepared fuels are obtained from primary fuels or derived from primary fuels. So these are basically charcoal, petroleum and coke. These are obtained by primary fuels. So these are called secondary fuels or derived from primary fuels. So the characteristics of a good fuel: it is readily available, burns easily in the air at moderate rate, less expensive, not so much costly, large amount of heat produced, easy to store and transport, high calorific value, does not leave behind any undesirable substance or ash, and eco-friendly in nature. These are the characteristics of a good fuel. What is the calorific value? Calorific value is the total quantity of heat liberated when a unit mass or volume of fuel is burnt completely. The unit of this fuel is in calorie, kilocalorie, and British thermal unit. What is calorie? And what is kilocalorie? What is the interrelationship between the British thermal unit and calorie? So here, this British thermal unit or calorie. Calorie is basically when you heat the 1 gram of substance and it rises the temperature by 1 degree Celsius. And in case if you take this in pound, then it will increase the temperature in Fahrenheit. Then it is called British thermal unit. So 1 kilocalorie is equal to 1000 calorie. And the interrelationship between the kilocalorie and the British thermal unit is 1 kilocalorie is equal to 3.966 British thermal unit. Or you can say that 0.003966 British thermal units per calorie. 1 calorie is equal to this much of British thermal unit, 0.003966. So this calorific value is to be classified into two types. First is the gross calorific value, or you can say that the high calorific value, and another is the lower calorific value. So what is the difference between the gross calorific value and the high low calorific value, or you can say that the net calorific value? In case of gross calorific value, the product of combustion have been cooled to room temperature. But in case of lower calorific value, the product of combustion are permitted to escape. We don't allow it to cool. They are allowed to escape in case of lower calorific value. Here the water vapor and the moisture are not condensed and escape as such along with hot combustible gases. Here we not recommend to cool the product to room temperature because this is allowed to escape in lower calorific value. What is the difference between the flash point and ignition temperature? Flash point is basically the indicator, general indicator that the chemical substance is flammable or not. It is the lowest temperature at which the fuel is ignitable by external heating source. For example, the flash point of acetone is minus 20. In some books it is written as 0 degree. So this is the minimum lowest temperature at which fuel is ignitable by external source. or ignited source. Ignition temperature, it is the minimum temperature at which fuel will automatically get ignited in the atmosphere. So how this process occurs? So when you heat the material, a chemical substance or liquid substance, vapor gets formed. And this is to be um, easily find the flash point and the ignition temperature. Now come to the bomb calorimeter. Bomb calorimeter is the instrument that is used to find the calorific value of a fuel. How the calorific value of a fuel is to be determined? This is to be determined with the help of bomb calorimeter. So, as you see in figure, here it is the bomb, and this is the basically ignited wires, ignition wires, and here is the oxygen supply. Without oxygen, how this fuel is to be burned? So here oxygen is provided with the help of this um, valve, and at least 10 to 25 atmosphere is to be maintained in this container bomb. Here a stirrer for uniform mixing, so that temperature is uniform. Here is a thermometer. This thermometer is a special thermometer that is known as Bachmann's thermometer. That is usually you calculate 1 by 1000th of the temperature. So here it is the insulating jacket that prevent the loss, heat loss. And here this is the steel bomb, and this is the ignited coil, and this in this crucible a fuel is to be taken to in order to find the calorific value of a fuel. This is basically the bomb calorimeter experiment. It is used to measure the calorific value of a solid as well as liquid fuel, but that to determine the calorific value of a gas, one needs to choose Junker's calorimeter. So calorimeter, we have already explained about the calorimeter. It contains a thick walled cylindrical vessel, and it consists of a lid that supports two electrodes that are in contact with the fuse and fuel sample of known weight. Before obtaining the calorific value, we measure the fuel, weight of a fuel. The lid also contains oxygen inlet valve through which high pressure oxygen gas at about 25 to 30 atmosphere is supplied. And the entire lid with the fuel sample is now held in a copper calorimeter. You look this figure again. This is called the copper calorimeter, and in this water is filled. So as the fuel gets burned, heat is released, and this is absorbed by the water. So as it absorbs the heat is absorbed by the water, the temperature of this rises. For this, a thermometer is provided to measure the temperature of the water. So it is the bomb and it is the copper calorimeter. A thermometer is provided to measure the change in temperature of water due to the combustion of fuel in the lid. So here, before going to the numerical part or the calculation part, you must be clear about the latent heat. So latent heat is the energy released or absorbed by a body or thermodynamic system during a constant temperature, usually a phase transition. So in generally, the solid is converted into the liquid and liquid is converted into the gas. So here the phase transition take place. So when so here two examples of latent heat are, first is the heat of freezing and the second is the heat of vaporization. So heat of freezing and heat of vaporization is simply explained the amount of thermal energy given off as a liquid freezes, amount of heat given off. But in case of vaporization, the heat of thermal energy that must be added to change a liquid to a gas. So here the amount of thermal energy given off and here the amount of thermal energy that must be added. So this is the heat of vaporization and heat of freezing. So here it is a simple calculation. In this fuel, we determine both the calorific value HCV and LCV. HCV high calorific value and LCV is lower calorific value. So here a known quantity of fuel sample is added into the crucible. Where is crucible? This is the crucible where the known quantity of fuel sample is taken. Start the stirrer and note down the initial temperature of the water. Stirrer is also provided. You please see, look into the figure. This is the stirrer. And you note down the initial temperature of water. Before the combustion take place, you please, this is used for uniform mixing. The heat released during the combustion of a fuel is taken by water and hence the temperature of water rises. So here two things, that one is heat is released and this heat released is to be absorbed by the copper calorimeter. Also as the heat absorbed by the water, the temperature of water gets rises. The final steady temperature of the water, high calorific value of a fuel is XL. X is the weight that is to be taken, um, and L is the high calorific value. So L is equal to capital W plus small w. What is this capital W? These capital W is the mass of water that is present in the copper calorimeter, and small w is the water equivalent of the bomb calorimeter. How this water equivalent is to be calculated? This water equivalent is to be calculated with the help of known sample. Known sample means, let us take an example of benzoic acid and other fuel that is already known. The HCV value or the high calorific value is already known. And the correction, temperature correction is also been noted in this case. T2 minus T1. What is this T2 minus T1? T2 and T1, T1 is the initial temperature and T2 is the final temperature after the combustion. So T2 is the final temperature and T1 is the initial temperature. And Tc is the temperature of correction for radiation losses if it is available. Cw is the specific heat of the water. So here LCV means lowest calorific value. What is this lowest calorific value? We have already explained that here the product that is obtained is allowed to escape. So LCV is equal to HCV minus latent heat of water form, and this you calculate this as HCV minus 0.09 H into multiplied by 587. 587 is the latent heat of steam, that is latent heat of steam is equal to 587 calorie per gram. So this is the simple formula that is used to determine the highest calorific value and the lowest calorific value of a fuel. In proximate analysis, we may calculate about the content of moisture, volatile matter and ash. These are determined experimentally. How this can be determined experimentally? This is obtained by simple formula. So, as you know that the moisture content, the amount of moisture that is present in the sample. So, lesser the moisture content, better is the quality of the coal. If the amount of moisture is more, then it is difficult to use it for applications, industrial applications. So moisture percent is to be calculated is loss in weight divided by weight of coal taken multiplied by 100. So what is this weight of coal taken? Initially, first you take the amount of coal that is equal to 1 gram, and after this you keep this in oven. So and after you put the temperature of the oven it nearly at 100 degrees Celsius, and after this you find the loss in weight. What weight is lost? Obviously at 100 degrees Celsius the moisture loss occurs. So the weight obtained after um, 2 hours when you keep this in oven at 100 degrees Celsius is less. So by this you calculate the loss in weight and you divide this with the weight of coal taken and multiplied by 100, you get the moisture percentage. Similarly, we may calculate the volatile matter. Lesser the volatile matter, better is the rank of coal. So loss in weight due to removal of volatile matter. How this volatile matter is to be removed? You keep the sample at nearly 700 degrees Celsius in a muffled furnace, not in oven. So at this temperature, volatile matter gets lost. And you find the loss in weight due to removal of volatile matter and divide this with weight of coal taken, weight of coal sample taken. This may give you the volatile percentage. Finally, you obtain the ash content, and this ash content is to be calculated. You keep the sample in a muffled furnace at nearly 900 degrees Celsius and obtain the weight of ash left divided by the weight of coal taken multiplied by 100. And here is the fixed carbon. Fixed carbon is to be calculated when you divide minus subtract this moisture, volatile and ash from 100, you get the fixed carbon percentage. So greater the percentage of carbon and hydrogen, better is the quality of the coal and calorific value. A good coal has very little nitrogen content. Sulfur is usually present to the extent of 0.5 to 3% and is derived from ores like iron pyrite and gypsum. Oxygen content decreases the calorific value of a fuel. High oxygen content coals are characterized by high inherent moisture content. So here by this we calculate the ultimate approximate analysis of fuel, and the other ultimate analysis of fuel is covered in next lecture. Thank you.